Hello and welcome to another one of D's ADD videos. Today we're going to be discussing trig substitution, a technique for integration. Trig substitution literally should be one of the very last things you try for integration. You should have gone through your list of algebraic manipulation, substitution by parts, partial fractions. All those other things don't work, then try trig sub. And the way you can recognize trig sub, or the way to go about these, is to look for certain key things. The box in these things can be any variable whatsoever. So if you have the box squared plus a number squared, the substitution that you would do is a tangent substitution. So an example would be if you had 4x squared or 9x squared plus 16. Okay, what you would do is you would let 9x squared be your box squared, so 3x squared root on both sides would be box, and that would go right there. And then doing the same thing with the numerical value, we'd have number squared equals 16, number equals 4. So your substitution in this one would have been set up initially like that. The next one to look out for would be number squared minus some variable squared. In that case, it's going to be a sign substitution. So what you want to do is, again, recognize that, and then let's look at 25 minus x squared. If you were to see something like that and you were doing trig sub, you know your box squared is x squared again, and your box will then be x. Number squared is 25. Number is 5. So you would write down x equals 5 sine theta. And then we have box squared minus number squared, and that one is a box. Box again is any variable, x, y. It could be 4x squared, 10x squared, whatever it is. But it has to be the variable term. This is a secant substitution. You have something like and that would be alright. So once you figure out which one of those basic scenarios it is, you set up the substitution. That would be the first step. Step 2 is to plug in to your integral. Step 3 is to find dx and plug that into the integral for dx. And when you're done with this step, you should all variables should be, I had two things trying to come out of my mouth at the same time. I was trying to say all the variables should be x, or you should have no x's. Either way you want to look at it, it should be true. So At this point, it should only be thetas. Alright. Then, hopefully you've made an easier integral, so you integrate. After that, you're going to substitute back in terms of x or y or whatever your original variable is. And you do that by setting up a triangle and using trig identities. How do you set up your triangle? Well, let's see. Let's take this expression up here where I had, let's look at this one right here. The x equals 5 sine theta. So if x equals 5 sine theta, I can set up a triangle that has a sine of x over 5, meaning that's your opposite and that's your hypotenuse. So once we have that, we have a right triangle. Here's our theta. The opposite is x, that's 5. And if you did it correctly, you do your Pythagorean theorem. Alright, we have x squared plus our missing leg squared equals 25 squared, or 5 squared, which is 25. So b squared equals 25 minus x squared, square root both sides, and you get that missing leg. And if you did it correctly, this expression should be in your problem somewhere that you're substituting. And let's say your answer was theta plus cosine theta plus sine 2 theta. How would you convert that back into x's? Well, theta would use this expression here. That's the relationship between theta and x right there. So if you arc sine both sides, you get that theta would be arc sine of x over 5. This is just a hypothetical problem I'm using to solve this. And then cosine theta, if I come over here to the triangle, cosine, if you remember, is adjacent over hypotenuse. So that's going to give you a root 25 minus x squared over 5. Plus sine 2 theta is a little bit more complicated. What you have to do is remember that sine 2 theta equals 2 sine theta cosine theta. Then we already know that sine theta is arc sine of x over 5. Oh no, that was theta, wasn't it? What is sine theta? That's just x over 5. Sorry. Glad I caught that before I got too far into it. Actually, let's go ahead and erase that and keep it in red. So we have the 2 from the identity right here, and then we have sine theta, which is x over 5, and then times cosine theta, right, which is root 25 minus x squared over 5. Alright, so again, recapping, find your scenario, whichever one of these three it is, then after that do your substitution, plug into your integral, find dx, plug that into your integral, should be all in terms of theta at that point. Then you integrate, substitute back in your original variable using a triangle and trig identities. Alright, I hope this has clarified any confusion that you might have over trig substitution. Make sure you check out the example video. Thank you and have a nice day.